Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to continue our water series, and today we're going to take a closer look at ozone water treatment. So let's dive right into it. Now first, before we understand how we use ozone to treat our water, we have to understand what the heck is ozone. So ozone is basically O3. So normally O2 is the normal state of oxygen, but if you have certain scenario, you can create O3, basically something like this. Generally it will be only like this much, and basically like this much. But if you have one extra free oxygen, basically O2 is the stable state, but if you break them apart, they both will become unstable. They will try to bond with whatever is nearby. So if they bond with another O2, then they create O3. This is what happens in our basically upper atmosphere where we have oxygen. So oxygen is there, so you have a lot of O2, but ultraviolet comes in. Ultraviolet is very high energetic and like in specific wavelength, and O2 absorbs it. Now when O2 absorbs it, the energy is like energy cannot be created nor destroyed. There is a consequence of that. It breaks apart. Now once that bond has been broken apart, that create two unstable oxygen. Basically instead of O2, now you have two O that is in ionic state, that is unstable, that want to bond with each other. Now given the fact that Earth atmosphere has a lot of oxygen, it ends up bonding with another oxygen. That creates the O3. Now O3 has this one annoying problem, that it is have very short half-life. Basically O3, if you take O3 and put it in a container, best container you can find, best seal, hermetically sealed, cryogenically frozen, it will self-decay. Basically in few days you will end up with nothing. Basically it's not like it will disappear into nothing, but it will become from O3 to O2, because O3 is inherently unstable. So you have to understand that you cannot make a tank full of ozone. I mean, like, you can do that, but only for a few minutes, because it will start decaying instantaneously, and basically in matter of few days even 1000 liters will turn into nothing. So this is a very critical aspect. It is very unstable. It does not have very long life. Now this also adds another advantage to it. Basically O2, even though it's very stable, it's not so stable that it will not bond to another anything. That's why your oxygen in the atmosphere can give corrosion to metals also. Now in terms of when we are talking about ozone is so unstable that it wants to get rid of that oxygen. It is unstable right now, so it wants to give rid of one whole oxygen, and it is itself is not basically stable enough. It is the most powerful oxidizing agent there is on the planet, flat out. There is no element that is more powerful than this in terms of oxidization. No chemical, no compound, nothing. So if you want to oxidize something, ozone is your best bet. Now this also gives the unique ability that it can bond with almost anything, including salts, including metal ions, including almost anything. So because it's like the most powerful oxidizing agent, that gives them the ability to bond with almost everything. So how do we use it in water now? If you have been following my water series, you must have learned the fact that in water we have three things: physics, chemistry and bio. Now when you are talking about basically biology, this takes care of all of it. Basically bacteria and virus both are destroyed by it. It does not suffer the same consequences of RO. RO can take care of big protozoas and big fungal and all that very easily, but viruses can come through it. That's why whenever you have RO, you always have to have UV treatment after it. Otherwise biomatter is like virus can still pass through. In this, nothing passes. Basically flat out, it's almost same level as UV in terms of sterilization. Now instead of sterilizing, it destroys the cell, because it's the cell wall of all the microorganism is inherently in a stable state. This extra unstable oxygen atom that comes and destroys it, and I'm talking about destroying it. Basically after a ozone treatment, you won't be able to find basically intact cell. You will find guts. Basically it will be destroyed. It's not like UV sterilization where okay, it's active, now it's dead. It's not like that. It's like active, destroyed. So it destroys bioorganics completely. Like you put ozone in one corner, it's done. It takes care of it, as long as you have enough of it. Now this takes care of biological aspect. Okay, your water is now pure of any bacteria and virus that can harm you. Awesome. But this also removes ions. Now this is the reason why anybody is even interested in ozone treatment, because if you have a lot of salts, if you have a lot of sulfur, especially if you are talking about places which deals with fertilizer, it is the one of the few things that can handle a fertilizer runoff. Basically if you have a lot of fertilizer land, fertilizer once starts to seep into what we call groundwater, it contaminates it. Like urea is a very bad thing. Like urea contaminated water is very unsafe for almost anything. It will kill fish, it will kill anything basically. So you want to remove urea, but the only way to remove urea is ozone, because ozone basically, think of this way, urea is this big, ozone breaks it down to smaller compounds, which is less harmful. or almost it neutralizes it. Now it also changes taste. Many places, if you drink water directly from a well, you will know the taste is very different. Now ozone changes taste because it is ionically bonding. Basically it's removing, let's say, magnesium, it's removing sulfur, it's removing all those things combined ends up changing the taste. Basically it is a water flavor control. Sometimes people like the taste, sometimes people don't like, but it does affect the taste. It's not like RO where taste won't be affected. This will affect the taste. Now fertilizer neutralizing, that inherently means if you are talking about basically soap, if you're talking about industrial runoff, you have to utilize ozone, because ozone is one of the few things that can handle these sort of things. Then how do we deal with it? Basically, you know for a fact that you can't carry O3, so we have to create it on site. How do we do it? Well, basically we take water, we take electricity, and we add catalyst. Now if you are familiar with the electrolysis, this sounds awful like it. Yeah, it is electrolysis. Basically you are overproducing oxygen by using high voltage and certain catalyst, and if high voltage is high enough, it will allow some amount of O3 to be created, but you have to make sure that hydrogen is vented off somewhere else. Now it does allow for very efficient creation and does allow very high amount of O3 to be created. That is like right now in all large water plants this is used. Then you have another option, is basically you use how our ozone is created. You create UV lamp and mix it with the air. Basically UV light of basically 185 nanometer will basically, if you have normal air running through it, it will basically make it into O3. Very low concentration. In terms of concentration, this will not make too much of it, but it is efficient and it does not create any byproducts. Now another that is like a bit between making with water or making with air, it's basically you use corona discharge. Basically you have high voltage and lightning between them. Now this happens naturally also when you have lightning strikes. This is created by default. Now we want to create it artificially. So if you are talking about a water treatment plant, you may have UV, you may have basically electrolysis, kind of bigger brother of electrolysis. So all these things are used to create on site, and these are very energy intensive. So how do we implement it? Now this is completely invert of basically UV. In UV you have to have very clean water. This does not like very clean water. I mean, like, it's not like you can't use it in clean water, it's just people generally don't put it at clean water. They basically, if you have water treatment plant, you will put it at very early stage before filtration. The reason for that is it creates byproduct, so you have to remove the byproduct afterwards anyway, so might as well do it before water is filtered enough. So the benefit of that, it also allows you to do basically activated carbon. You have to do that because ozone is the actual thing there. It's not a radiation, it's actually physical element there. It creates physical byproduct which you have to remove using activated carbon. Now activated carbon neutralizes it, takes care of all the heavy particles and ions that are created. The benefit of that, it also helps in coagulation. Basically if you have a filter, basically a heavy pond of water or for water treatment, if you put ozone into it, it will help basically small ions to become big stable ions. Basically it will become heavier salts that will allow them to sediment much more easily. So it actually helps basically in another process. That's why people want to do ozone before it goes into activated carbon. This will help activated carbon to remove much more efficiently. So it's not something like you do at the last. Basically UV is the something you do at last, this is something you do at first. Now you have to make sure, in same way in UV you have basically you have to make sure the radiation exposure is matched. In this, contact time must be taken care of. Basically they will tell you like, okay, for 1 ton of water you must have ozone, this much concentration of ozone for at least 15 minutes. You have to make sure of that. Even though it's not basically like line of sight, it's not like rays going through each, you have to make sure there is enough time for ozone to react. If it does not react appropriately, you can have a scenario where this coagulation will not work and you will either damage the activated carbon or flat out damage other things that are after it, because O3 is very reactive. You have to let it time for like, okay, just chill, decompose, chill down, because if you directly feed O3, active O3 into RO membrane, the membrane will be destroyed. Not destroyed as in like it won't explode, but the efficiency of your RO membranes will go down, and then after a while contaminants will start to pass through it. So we have to make sure O3 is like given enough time to do its magic, because you don't want to rush it. Basically in UV case you have to make sure the exposure is matched. In this you have to make sure the time is enough. Now are there any side effects? If this is the only thing that can take care of biology and chemistry, why the heck we don't use it everywhere? Well, it does suffer with one random consequence, that if your water source, whatever, be it river, be it deep bore well, has bromide into it, bromide plus ozone equals cancer. That's the weird problem ever. And many of you are who are living in America must be familiar about California doing like covering a pond with black balls. The reason for that was this: it was not to stop evaporation. That was an added bonus, but the main reason was to make sure the UV exposure is goes down. So bromide was there. There was always some bromide. But if you have bromide, bit of ozone, and lot of ultraviolet, it creates more of it. And the water companies that were making bottled water using that reservoir water, they were complaining, is like, dude, why the heck you are giving us cancer? So you have to understand, this is why before you use ozone, you must check your bromide level. If it's below a certain threshold, it's like 10 part per million, you're okay. But if it's like anything above that, government will flat out ban you. Then it's very energy intensive. If you are only doing this for biological contamination reasons, basically you want to make sure that I'm not going to get sick because of basically cholera or things of that nature, it's not very efficient. You want to use UV for that sort of scenario. Now byproduct, it does create byproduct. It's not like UV where you have just like water running through a canal and UV is sterilizing it. It will create byproducts. Now if you filter it out, awesome. If you don't filter it out, it's not that those are toxic, but it's like carbon dioxide. If you have too much of it, let's say in case of human environment 13%, you did, byproduct has to be taken care of. Many times you will hear people say fancy things like ion exchange membranes. Those things are there to just take care of those fancy things. Now on top of that, it's still manageable. It's still one of the few things that can help us take care of basically contaminated groundwater because of the irrigation environment and like fertilizer runoff. It does suffer from the same problem that UV also suffers from. It's basically, it's still prone to reinfection. Basically you can't disinfect the water in one part of the country and send it to another part. You have to mix chlorine in again. Basically everything boils down to this fact: can you purify the water? The short answer, yes, very easily. We can do it without any issue. Can we transport that water from point A to point B without worrying about contamination? Yes, in bottled scenario. But if you have to send like let's say city worth of water, you have to add chlorine. This is the biggest roadblock basically. That's why nobody is like, let's just use UV everywhere. People are like, okay, we have to add chlorine to make sure that it's not reinfected. Let's just add a lot of it. And chlorine also takes care of the same things. So this is why ozone is not used everywhere, because if you have groundwater that is already contaminated by bromide, you have to double check it. Otherwise you might be exposing yourself to much higher cancer risk. It's not like you're gonna drink bromide contaminated water with ozone treatment, you're gonna die, but it will increase your risk. So it is something that you have to take into careful consideration. Now, this was my presentation on ozone water treatment. I hope you liked it, learned from it. In that case, please leave a like. If you didn't like it, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment. And I would ask you to leave a comment because I reply to all of them. Please subscribe, press the bell icon if you're free. And as always, thanks for watching.